Good afternoon, everyone. My name is Apurva Sarkar. My ID is 2321529 from the Department of Computer Science and Engineering at Daffodil International University. This presentation is for my Numerical Methods course under the guidance of our respect course teacher Mr. Devashish Kumar. Today I will be presenting on numerical methods, error, roads and interpolation, showing partial example and solution for each topic. Now I would like to begin with the first problem in my presentation, which is about error analysis. First, I will briefly describe the problem. We are given a mathematical expression, square root of 65 plus square root of 120 minus square root of 50. Our goal is to calculate different types of errors based on this expression. Now before going into the solution, let me explain the basic idea of error analysis. When we solve a problem approximately, maybe by rounding off the using limited digits, there is always some difference between the exact value and our approximate answer. That difference is called error. We calculate three main types of error. They are absolute error, relative error and percentage error. Let me explain the formula step by step. First, the true value is the exact result of the expression. Calculate using a calculator or software with full precision. The approximate value is calculated by rounding its square root to 4 significant digits and then performing of operation. To find the absolute error, we use this formula. Absolute error equal true value minus approximate value. To get the relative error, we divide the absolute error by the true value. Relative error equal absolute error by true value. And finally, for percentage error, we multiply the relative error by 100. Percentage error equal relative error into 100%. Using those formulas, we will now solve the problem step by step in the upcoming slides. Question 3. Today we are going to solve a problem about estimating the value of industrial equipment using Newton's divide difference interpolation and Lagrange interpolation. Our problem is to find the estimate value of a piece of industrial equipment in the year 2019. We are giving the following data. Year X equal 2018, 2020 and 2022 and last is 2024. Value of Y is 15.0, 12.05 and 9.0 and last is 3.5. First of all, we need to know what is Newton's divided difference interpolation. This method is highly effective for data points that aren't equal spaced, but it works perfectly fine for equally spaced data as well. Step 1. Create a divide difference table. First, we need to construct a divided difference table. This table will help us find the necessary coefficient for our interpolation polynomial. This is the divided difference table. Let's quickly see how we calculate those values. First divided difference is minus 2.5, minus 3.5 and minus 5.5. And second divided difference is minus 1.0 and minus 2.0. And last is third difference is minus 1.0. Values from the difference table. Y naught equal 15.0. Delta Y naught equal minus 2.5. Delta square Y naught equal minus 1.0. And delta cube Y naught equal minus 1.0. Step 2. Calculate P. The formula for P equal x minus x naught by h. The calculation of P. P equal 2019 minus 2018 by 2 equal 0.5. Step 3. Apply Newton's divide difference formula. The formula is a sum of terms where each term uses the coefficient we just found. This is the formula. Let's plug in our values and calculate for x equal 2019. Applying the formula step by step, and the finally calculate value is y 2019 equal 13.8125. Now we will apply Newton's Lagrange interpolation. So first of all, what is Newton-Lagrange interpolation? Lagrange interpolation gives us the same answer and is a great way to double check our work. Step 1. The general formula of Newton-Lagrange interpolation. The formula for Lagrange interpolation is the sum of terms where each term is product of a y value and the basic polynomial. So this is the expand formula. Step 2. Calculate the basic polynomials Lix. We have already calculated those basis polynomials for x equal 2019 in the previous example, which are L0 2019 equal 0.3125, L1 2019 equal 0.9375 and L2 2019 equal minus 0.3125, and last is L3 2019 equal 0.0625. Step 3. Calculate the final value. Now we multiply each y value by its corresponding the basis polynomial and add them up the final summation steps. And last is the final calculate value is P 2019 equal 13.8125. There are two is same. Final answer. Using Lagrange method, the estimate value of the equipment in 2019 is 13.8125 lakh taka, which is same answer we found using Newton's forward interpolation method. Thank you so much for watching me.